Today we're going to start working on exponents and how to deal with them. And for the most part, everything we do on exponents, you will be able to expand out all of your exponents, cancel out, and simplify to the answer. There's two main rules that I need you to understand in order to work with exponents. The first one is what to do when you have either a letter or a number that's been raised to the power of 0. So if we look here at our 0 exponents, the rule to know is anything raised to the power of 0 equals 1. So 3 raised to the power of 0 is 1. 5 raised to the power of 0 is 1. Negative 10 raised to the power of 0 is 1. Really simple. If you see something raised to the power of 0, you're in business. It's 1. The other big rule to know is how to deal with negative exponents. We cannot have negative exponents as our answer. So the thing with negative exponents is we have to move them. And what we're always dealing with is when we have a problem, you can always think of your problem as a fraction. It's got the top line and the bottom line. So even this first one right here, this example, it just showed the top line, like a whole number. Anytime you have like a whole number, to turn it into a fraction, you just put it over 1. So we're taking our a to the negative n exponent and putting it over 1. The way to deal with negative exponents is you have to move them. If they are sitting on the top and they're negative, you move them to the bottom. If they're sitting on the bottom and they're negative, you move it to the top. So what we have right here is a to the negative n. Right now it's on the top line. In order for us to make this a positive n, we're going to have to move it to the bottom line. So we always start by just drawing our line, and we're going to move this a to the nth power to the bottom. Now notice when I moved it to the bottom, I took away the negative. It's no longer negative. I moved it to the bottom. That took care of the negative. Now I don't have anything on top. If I don't have anything left on top, there's always a 1, and that's my answer. So when we start working with exponents and we're dealing with negatives, I'm going to tell you the same thing every time. Draw your line, and the first thing we have to do is move everything so that all of our exponents are positive. Okay, so let's look at a couple of examples. Okay, so as we learned, 3 raised to the 0 power, anything raised to the 0 power is 1. Now on number 2, what this really is, and this is kind of weird, so I'm going to explain it to you, is this is really negative 1 times 2 raised to the 0 power. So 2 to the 0 power we know is 1. Negative 1 times 1 equals negative 1. It would be different if that negative 2 had been in parentheses and the whole parentheses were raised to the 0 power. But since they're not, we only have to look at the 2 being raised to the 0 power. Okay, so as we look at number 3, we've got a negative exponent. So I'm going to go ahead and draw my line, because I know I'm going to have to move things from top to bottom or bottom to top. So I need to draw my line. Okay, right now I have my 3 over 3 to the negative 4 exponent, and I'm going to write it as a fraction. So I'm going to go ahead and put it over 1. So right now it's on the top, but we have to move it so that it becomes a positive exponent. So we're going to move it to the bottom. And notice that my negative 4 now has become a positive 4 because I've moved it. There's nothing left on top, so I'm going to put a 1. Okay, number 4. On number 4, I'm going to go ahead, just a typo, that negative 4 was supposed to be in parentheses. So we've got negative 4 in parentheses raised to the negative 3rd power. So we're going to move our negative 4 in parentheses to the bottom and get rid of our negative and put 1 on top. Okay, go ahead and try number 5 number 6, number 7 on your own, and then check back and see your answers. Okay, so quickly check your answers. I forgot to tell you that there is parentheses around the -3 on number 6, so that probably will impact your answer. Okay, and then now let's move on to number 8. And on number 8, we've got our -5 is also supposed to be in parentheses. So we've just got a 1/3 raised to the +1 power. So there's our answer. All right, so now let's look at it with just dealing with letters as well. Letters are the same as numbers when we're dealing with exponents. So z to the 0th power equals 1. And then on number 10, we're going to draw our line. We've got to put the a to the 8th power on the bottom and a 1 on the top. Okay, the easiest way to deal with something like number 11 is go ahead and just split it apart, and let's look at what we're dealing with. Because what we're really dealing with here is 6 times a to the 0 power times b to the -2. So all I did was just split it into its 3 components. Now let's draw our line and start dealing with everything. Okay, the 6, there's nothing bad or weird about it. It's just going to go there on top. How do we handle a to the 0 power? What is that? That's really just a 1. So we're not going to do anything with it. So just 6 times 1 is 6, so we're just going to leave the 1 alone. And then we've got this b to the -2nd power. So we need to put it on the bottom, b, and now it becomes to the +2nd power, and that's our answer. Okay, so number 14, we're going to use the same thing that we just did. This is really just 14 times m to the -4th times n to the 0. And we know this n to the 0 is a 1, so we're not going to have to do anything about it. So our answer, we'll draw our line, our 14 is going to go on top, and we're going to have to move our m to the 4th to the bottom, and that's our answer. Okay, so go ahead, and I want you to try number 13 and 14 on your own. Turn off the video, turn it back on, and check your answers. Okay, 13 is very straightforward. On 14, some of you may have ended up with your answer looking like this guy on the top. I went ahead and said, since I was dealing with numbers, I went ahead and simplified it on down, and 2 cubed is 8. So 8 times 8 is 64. That's how I got the 64 to go on that answer. Okay, let's turn the page. On the second page, there are rules that go with how to work with your powers. We're really not going to deal with the rules. I want you to learn by expanding everything, expanding and canceling. Some of you will see the patterns and the rules, and you may start using the rules. But for the most part, I want everyone to just expand. If you're a pattern person, you will see the rules and you'll naturally start doing it. If you're not, don't worry about it. Don't get caught up in all of that. Just work on the expanding and canceling out and getting everything to the right spots. Okay, so with that in mind, we're going to ignore that first box, and we're just going to start by expanding. So we have x to the 4th. It's 4 x's. 1, 2, 3, 4. Times x to the 7th. So our answer is x to the, how many x's do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. X to the 11th is our answer. Okay, so I want you to go ahead and try 17, 18, and 19 on your own. Pause the video, come back and get the answers. Okay, check your answers, make sure you got the same ones. Now, number 20. Number 20 confuses sometimes people when you start looking at the exponents. So we have this exponent of the fourth power. That is going to the b. The b is being raised to the fourth power, but the a does not have an exponent with it. So when I expand this out, I have 1a and 4 b's. Then when I expand out my second one, I'm just going to go ahead and put it in parentheses. My second one, I still just have 1a, I have 2 b's, and 1 c. So now that I've expanded it out, I can start counting and combining. So how many a's do I have? I have 2, so a to the second power. And b's, I have 6 of them, so b to the 6th power, and 1 c. That's my answer. Okay, so we're going to use that same process that we just used on number 20, and we're going to use it on number 21. We're going to expand everything out. The big difference on number 21 is we're going to have to deal with some coefficients. So this very first one expands by 4 times x times x times, looks like 3 y's, y, y, y. Okay, that's my first one. And my second one, my second term is 6 times, there's 12 x's, so I'm going to write them fast. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1 y. Okay, so now that we've got them expanded out, we can start multiplying and combining. We have to deal with our coefficients like normal numbers, like we always have. So we're multiplying. What is 4 times 6? What's 24? Okay, now we have to deal with our x's. I've got 2 in the first term and 12, so that equals up to 14 x's written down there. And then I've got 1, 2, 3, 4 y's, so y to the 4th. And that's my answer. Okay, so some of you have seen the pattern, seen what the rule will be. If you see the pattern, you'll have already seen it. And if you don't worry about it. But what's really happening on our pattern is we're adding our exponents. So if you look at these x's, we had 2 over here, we had 12 over here. 2 plus 12 is 14. On our y's, we had 3 over here, and we have 1. 3 plus 1 is 4. So based on that rule, we could say that a to the m plus n power. We're just adding our exponents. Like I said, don't worry about the rule. If you see it, use it. If you don't, expanding it is the safe way to go. Okay, so now let's look at them when we're doing division. We're working with quotients. So let's expand it out. We have 7 x's on top. We have 2 x's on bottom. Okay, so we can cancel out 2 sets of x's. Do I have anything left on bottom? No, I don't, so I don't even have to worry about the bottom. How many x's do I have left on top? I count 1, 2, 3, 4, 5. So my answer is x to the 5th power. Okay, let's do the next one. We got 3 m's on top, and we got 5 m's on bottom. When I start canceling, I can cancel out 1, 2, 3 of them. That leaves me with 2 m's, or m squared. Is it on top or bottom? This is where I see people mess this up. It's actually on the bottom. So we need to make sure to put it on bottom. And since there's nothing on top, we just put a 1. Okay, so this time, number 25, we actually have some numbers to deal with as well as letters. So we have a 6 times x, x, x over 9 times x, 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 x. Okay, so first let's deal with our coefficient, our fraction. 6 over 9, does that reduce? Well, it does. It actually reduces into 2 over 3. So now I've taken care of my numbers. That's as much reducing as I can do there. Now let's take care of my letters. I can cancel out those 3 x's. Do I have anything left on top? No, I don't. I do have some x's on the bottom though, so that's going to be x to the 2nd power. So that's my answer, 2 over 3x squared. Okay, let's look at number 26. I'm going to give us some room to expand this out. We have 18 times x to the 5th, so x 2, 3, 4, 5 times y. That's our top. And then our bottom expands into 3 times x to the 4th times y. Okay, now that we have it expanded, let's start canceling out and getting it simplified. So let's just start right here with the 18 and the 3. That's our numbers. 18 divided by 3 ends up being just a 6. So on our top, we now have 6 over 1. That's how our 18 over 3 reduced. Now let's cancel out x's. We go 1, 2, 3, 4 sets of x's that'll cancel out, and I'm left with 1 x on the top. So let's put it there. And then my y's also cancel out. So really, I'm just left with 6x over 1, which can just be reduced to plain old 6x. Okay, number 27 and 29. I want you to go ahead and try 27 and 29 on your own. Pause the video, come back and look at the answers, and then we'll discuss number 28. Okay, biggest problem I saw people doing on number 27 was making sure that you realize your x's end up on bottom. So negative 5 over x squared, and then number 24 is 4 raised to the 4th power. So again, on these rules, if you see the pattern, you've probably already seen it. If you don't see the pattern, you probably won't. But what the pattern is on this is we subtract our exponents. So 7 minus 3, if we're looking right here on number 29, our exponent is 7 minus 3 is 4. So 4 to the 4th. The problem with this rule is when you get onto something like number 27, it's 2 minus 4 is negative 2. So you would have to know that your exponent ends up on bottom to be positive. That's why normally I just tell everyone to go ahead and expand it out. It keeps you from making mistakes. But our rule is a to the m minus n. Okay, if you have any other questions on this, feel free to come into tutoring after school or before school.